Okay, here's a problem where I have a circle and a straight line, and I have to find the coordinates of the points where they intersect. So, points of intersection, this is simultaneous equations, but this time I haven't got either equation in the form y equals. So I am going to solve this by substitution, but I've got a bit of work to do before I can do a substitution. I need to get one equation in a form where I can substitute into the other. And the easier one to get into that form will be the second one. But I'm not going to make y the subject. If I make y the subject, then at some point I'm going to have to divide by this 2, and I'm going to get fractions times x, and I would like to avoid fractions. So, in fact, I've got a choice. I can either substitute in for y or for x, and x is easier to make the subject of this formula. So if I do that, if I take the equation and I say I'm going to add 2y to both sides, and I'm going to subtract 2, I'm going to get for the line that x equals 2y minus 2, and I'm going to substitute that into this equation. So it's going to have exactly the same form. I'm not going to try and do too much work at once. I'm going to leave everything alone that I'm not actually substituting in for. So it's just the x is going to be replaced by 2y minus 2. So 2y minus 2 in this bracket. Okay. And then that bracket I can see simplifies to 2y minus 5 squared. And I'll still leave these other bits alone. It would be okay to go straight to this line if you're confident. Okay. But now I've got two brackets to expand out. You can probably see this is going to turn into a quadratic equation for y. Okay, but I've got a couple of grids to do. Okay, so use grids to square this out. So 2y times itself is 4y squared. 2y times minus 5 is minus 10y, and so on. I get 4y squared minus 20y plus 25 for the first bracket, and y squared plus 2y plus 1 for the second one. So now all I've got to do is collect my terms. So altogether I've got 5y squared. In terms of y's, I've got minus 20y here, but I've got plus 2y, so that's minus 18y. And then in numbers I've got 25 plus 1 is 26, but I'm going to subtract 17 from both sides because I want equals 0. So 26 minus 17 is plus 9. Okay, so this is the quadratic equation I need to solve. So I need another grid. It's bound to be y times 5y to get the 5y squared. In order to make the plus 9, well, I'm clearly going to need some minuses because there's a minus sign there. So it's just a question of experimenting till we find the right way to create the plus 9. And it turns out that a minus 3 and a minus 3 will do the trick, because that will give me minus 15y here and another minus 3y there, which gives me the correct middle term. So, using that factorization, I have that y minus 3 times 5y minus 3 equals 0. So the possibilities are y minus 3 equals 0, 5y minus 3 equals 0. So this one gives me y equals 3, and this one gives me 5y equals 3, so y equals 3 over 5. But I haven't quite finished, because these are the y coordinates. I wanted points of intersection. Okay, so I wanted coordinates. So for every y coordinate there'll also be an x, and the easiest way to find the x's is to use this version of the equation of the line. So x equals 2y minus 2. If I come down and use that for each one here, so for this one x is going to equal 2 times 3 minus 2, which is 6 minus 2, which is 4. And for the other one, x is going to equal 2 times 3/5 minus 2, which is going to be 6/5 for the 2 times 3/5, minus 2 is 10/5, so that's minus 4/5. So my 2 points are, get them the right way around, x coordinate first, so 4, 3 is one of the 2 points, and the other one is going to be minus 4/5, 3/5. And that's how we find the intersections between a straight line and a circle.